Hello guys, welcome back to my channel Algorithm Minds. My name is Asan Khurram and in this channel I teach programming skills in Python, MATLAB or R programming. I also teach theoretical concepts as well as practical programming skills in data analysis, statistical analysis, machine learning or data science. So if you are a person who wants to learn programming from scratch or if you are a person who wants to excel his career in data science, I request you to subscribe to my channel and hit the notification bell icon button. I have published a series of videos regarding Python programming and also the statistical analysis in Python programming. Today I'm going to start a new series of video regarding R programming where I will teach you about the fundamentals of R programming. We will take far from the very basic how to define a data type in R programming to the very end of the lectures where I will be describing about the data frames. So in today's lecture, I'm going to discuss about the data types in R programming. In this tutorial, we will explore various data types in R programming. Understanding the data type is the fundamental in programming as it allows us to handle and manipulate data efficiently. We will cover the following data types. We have numerics, we have integer, we have character, we have logical, we have complex and factor. So these are all the data types I'm going to cover in this lecture. But that's not it. I'm going to cover the following data structures also in this lecture. I will discuss about vectors, lists, matrices, and finally data frames. I will give you a brief overview of data frames so you can actually grab the idea of data frame. So let's move on and jump on to this tutorial. So first of all, let's discuss about numeric data type. So numeric data type is used to represent the real numbers, both positive and negative, with or without a decimal point. Examples of numeric data are such that we have 3.14, minus 42, 0.99, and 5. But how we can actually define numeric data in R programming, so that's what I'm going to teach you right now. So in order to do that, we are going to first initialize a variable named numeric underscore var1. Then I'm going to assign its value by using this assignment operator. And then finally, I'm going to write the value which I'm going to assign to this declared variable, which is 3.14. Here assignment operator will assign the value that is written on the right hand side to the variable that has been declared on the left hand side. So that's how you can actually declare a numeric data type in R programming. In the same way, I'm going to assign a new variable. I'm going to assign a new variable whose name is numeric underscore var2, and I'm going to assign a value that is equal to minus 42 by using this assignment operator. In the same way, I'm going to assign another value to another variable named numeric underscore var3, and I'm going to assign it value by using this assignment operator, and I'm finally writing the value that I'm going to assign, that is 0.99. And finally, if I want to assign another value, numeric data type, I'm going to use the same statement of R programming. First of all, I'm going to initialize a variable name numeric underscore var4. Then I'm going to assign a value by using assignment operator, and finally writing this value 5. So that's how you can assign values, numeric data type in R programming. So variables in R, variables are used to store data. You can name a variable almost anything. For example, numeric underscore 1 or numeric underscore var2 or var3. But it should be meaningful and descriptive. Assignment operator, the assignment symbol here is used to assign values to the variable in R. You can use the equals to sign, but here this sign, which is the less than and dash, is the traditional R syntax. So in R, simply typing the name of a variable in the script and running it will print its value to the console. So once we have actually assigned its value, when we are going to print its value to the console in R, you can easily do that by typing the variable name and running the code. This will automatically print the value to the console. So if you can see that I have actually wrote the values of all 4 assigned variables: numeric underscore var1, numeric underscore var2, var3, and var4. Let me just run this block of code for you so you can see. Now you can see that our numeric data type has been printed to the console. But I'm more interested in actually to know about the class of this data type, because in this lecture we are more interested in assigning different types of data. So I'm interested to know what is the class of this data type that we have assigned earlier. So I can do that by using the function class in R programming. This class function will help us describe what is the actual data type of the variable declared. So in order to do that, first I'm going to call the function class, and within this input argument I'm going to write variables I have declared earlier. In our case is numeric underscore var1 and numeric underscore var2. That will actually help us identify what is the actual class of the data type that has been defined earlier. So let me just run this block of code for you. Now you can see that we have both of the declared variables, numeric underscore 1, numeric underscore var2, we have numeric data type. So that's how you can actually declare numeric data type in R programming. Let's move on and discuss another data type in R programming, that is integer. Integer data type is used to represent the whole numbers without any decimal point. In R, integers are declared by appending an L to the number. Example of integer data are 5L minus 3L, 42L. So basically, when you want to define an integer, you will write an L at the end of the number, which will help R programming identify that this is an integer data type that you are trying to declare here. So what we are going to do, first of all, we are going to initialize a variable name integer underscore var1, where any variable name. Then we are going to assign its value by using this assignment operator, and finally I'm going to write the value 5L. Remember, in the R, if you want to declare an integer, you will write L at the end. So that's how you are going to define integer. In the same way, I have to declare integer values for other variables as well. As you can see, for the integer underscore var3 and assignment operator, then 42L. Once I have initialized and declared the values, I'm going to print this value by simply writing the variable name as I have defined earlier. So I have written all those three variable names in order to display its value to the console. And finally, I'm also interested to know about the class of this data I have actually declared earlier. So in that case, I'm going to use the function class and I'm going to pass input argument one of the two variables we have declared earlier for the integer data type. So integer underscore var1, integer underscore var2. Let me just run this block of code for you. Now you can see that we have successfully initialized and declared integer data types, and we have also printed its values 5, minus 3 and 42. And we can also see through the class function that its class and data type is actually integer. So that's how you can actually define an integer in R programming. Let's move on and discuss about another data type which is quite famous, and you are prone to use it again and again in R programming if you are not dealing just with numeric calculation. So that is character data type. So character data type is used to represent the text. Strings are enclosed in either single or double quotations. So how you can actually define a character data type by defining it into a under a single quotation or a double quotation. Examples of character data type are hello, which is again in a double quotation, R programming, which is again in a single quotation, and 1, 2, 3, which is a numeric, but it is defined in a double quotation, so it's now a character. So let me define those character types in R programming. So first of all, I'm going to initialize a variable name character underscore var1, and then I'm going to assign its value by using this assignment operator, and finally writing the value of character I want to assign to it. In that case, I'm assigning hello, which is put inside a double quotation mark. In the same way, I'm going to assign another variable, the character underscore var2, and I'm going to assign a value R programming that is contained in a single quotation mark. In the same way, I'm going to assign another variable, character underscore var3, and I'm going to assign its value 1, 2, 3 within double quotation mark. So once I have declared my character data type, I want to print its value. So I'm simply going to write the variable name I declared earlier, and when I run the code, it will just simply print the values on the console or in our Jupyter notebook output results. And finally, I'm also interested to know about the class of the data type declared earlier. So in that case, I'm going to use class function of the R programming, and then within those class, within those brown brackets, I'm going to pass the input argument or declare variable we have used earlier, that is character underscore var1 and character underscore var2. Let me run this board of code for you. Now you can see that we have actually successfully defined our data. Then we have successfully printed the values into the output results. As you can see, we have hello, R programming on 1, 2, 3. And finally, we are also able to see that the character type, data type of these declared variables are actually character data types. So that's how you can actually define a character data type in R programming. Let's move on and discuss about another data type, which is called logical data type. So logical data type is used to represent Boolean values, which are true and false. These values are often used in conditional statements and loop. Examples of logical data types are true and false. So unlike character data types, they are not you put into a quotation mark. They have only two values, either true with all uppercase letter and false with all uppercase letters. So that's how you can define a Boolean value or true for logical data type. So in order to do that, first of all, I'm going to initialize a variable named logical underscore var1, and I'm going to assign its value by using assignment operator and writing the whole true as an uppercase letter. In the same way, I'm going to declare another variable underscore var2, and I'm going to assign its value false by where each value character is uppercase. So that's how you can actually declare a logical data type. Finally, once I have declared the values, what I'm going to do, I'm going to print the value to the console. And also I'm interested to know about its class data type. So in that case, I'm going to call the function of class of R programming. And within those round brackets, I'm going to pass input argument logical underscore var1 and logical underscore var2. So let me just run this block of code for you. Now you can see that we have successfully printed the values of our declared variables and the output results true and false. We have also checked that the data type of these declared variables are actually logical. So once we have discussed about logical, let's move on and discuss about another data type, which is called complex data type. So complex data type is used to represent complex numbers. A complex number has a real part and an imaginary part. Examples of complex data are 3 plus 2 iota, 1 minus 1 minus 1 iota. So these are the complex data type that you can actually that we need to actually define within the R programming environment. So in order to do that, first of all, I'm going to initialize a variable name complex underscore var1. Then I'm going to assign a value by using this assignment operator. And in order to define a complex number, simply you have to write 3 plus 2i for I for iota. In the same way, I'm going to declare another variable name complex underscore var2, and I'm going to assign its value by using this assignment operator. And I'm going to write its value by simply writing 1 minus 1 I for iota. So that's how you can declare complex values. And once you have declared the complex value, we are going to simply print the values and also check the class of the values. What is the actual class of the declared variables? So let me just run this block of code for you. Now you can see that we have successfully printed the values, that is 3 plus 2i, which is I for iota, and 1 minus 1 I for iota. And also you can see that the data type of these declared variables, newly declared variables, complex variable 1, complex var 2 are actually complex data types. So that's how you can declare it. So that's it for, that's more than enough to help you get started with R programming. So right now we are going to go towards some more advanced or a little bit more advanced topics in data types, or how we can actually find more advanced data structures and data types in R programming. So that's what I'm going to discuss right now. So let's move on and discuss about the factor data type. Factor data type is used to represent the categorical data. Categorical data, like for example, you have a survey questionnaire where the response is either male or female, or the answer to the question is either yes and no. So that's why we call it categorical data. So in that case, factors are used in statistical modeling and data analysis or survey analysis. Examples of factor data are such that, for example, you have a question where you define the gender of the person who's giving the questionnaire. So in that case, he could be either male or she could be either female. And you can also ask some questions that the answer to the question could be either yes and no. So this is a categorical data. So how we can actually define categorical data or a factor in R programming? That's quite easy to do, and I will help you explain it with the help of this Python block of code here. So first of all, I'm going to initialize a variable named factor underscore var1. Then I'm going to assign its value by using the assignment operator. Then I'm going to call the function factor. Okay, so I'm going to repeat it. I'm going to call the function factor of R programming, which will help me convert this character vector here C into factors. Okay, so this factor function takes an input argument this here, which is known as character vector. Okay, so how you define a character vector? You will write C, and within those curly bracket, within those round brackets, you will write its values. Okay, male, female, female, male. So that's how you write values of character vector. Once you have defined the character vector inside a factor, you are successfully able to convert what? A character vector into a factor. So that's how you can actually define a factor in R programming. So that's how it's done. Now in the same way, I'm going to declare another variable named factor underscore var2, and I'm going to initialize its value. I'm going to assign its value by using this assignment operator. Then I'm going to call the function factor of R programming, and within the input arguments, within those square round brackets, I'm going to define another character vector, and the character vector is defined by C, then round brackets, and within those round brackets I'm going to write the values with where each value is separated by a comma, and each value is a character, so it must be defined in a double quotation mark. So that's how you define factors in it. Once you have successfully defined the factors in R programming, I'm simply going to display its value to the output by simply typing its name. Once I've done, then I'm also interested to know about the class of the declare variable. So I want to see what does it give us. So is the class of the variable is factor or something else? So let me just run this block of code for you. Now you can see that we have first one we have male, female, female, male, which is the factor form, and then for the second one we have yes, no, yes, no, and the correct data type of this type of data is actually a factor type. So you can see that. So what are levels? Levels are the unique values of your character vectors. In our case, the level of factor underscore var1 will be male, female, and the levels of factor underscore var2 will be yes and no. So that's how you can define it. So let's move on and discuss about data structures. So here we will discuss about more about how we can define multiple values within a single variable. So that's where data structures comes handy. First of all, we have vectors. Vectors are the most basic data structures in R. They are the sequence of data elements of the same basic type. So you have to remember that in vector you will define the data has to be of same data type. If you are defining numeric, it has to be numeric. If you're defining character, it has to be only character. You can create a vector using the function C. Examples of vectors for numeric are 1, 2, 3, 4, and for character are A, B, C. So how we can actually define a character variable, how we can actually define a vector variable is simple. First of all, I'm going to initialize a variable like numeric underscore vector. Then I'm going to assign its value by using the assignment operator. Then I'm going to call the function C of R programming, and within those round brackets, I'm going to write the element which I'm going to define within a vector. In our case, I'm going to define numeric values 1, 2, 3, 4. In the same way, I can also create another vector which is known as character vector. Okay, in that case, the elements must be character in it. So first of all, I'm going to initialize a variable named character underscore vector, and I'm going to assign a value by using this assignment operator, and I'm going to call the function C of R programming, and within those round brackets I'm going to pass input argument which are the characters. Okay, because I'm defining here characters only. So the character has to be defined in double quotation or single quotation, and every element has to be separated by a comma. So that's how you can define a character vector. Finally, I can in the same way I can take another data type and make a vector out of it. For example, I can take boolean values or logical data type and make a vector out of that. In that simple, I'm going to assign a variable name logical underscore vector, and then I'm going to assign its value by using Simon operator, then calling function C of the R programming, and within those round brackets, I'm going to pass input argument our data, where each value will be separated by a comma, and logical and boolean data types are represented here, either true and false with all uppercase letters. So let me just run this block of code for you. Once I have defined that, I'm simply going to print this value by simply typing the name of the variable in our program, and once I run the code, it will simply print the values. So now you can see that we have successfully printed the values of our vectors. The first one was the numeric, the second one was character, and the last one was actually logical. So once we have done that, I'm also interested to know about what is the data type of this vector we have created. For that purpose, I'm going to use the class function of R programming, and within the I'm going to pass input argument within those round brackets the variables we have declared earlier: numeric vector, character vector, and logical vector. So let me just run this code for you. Now you can see that the numeric vector is actually the data type of numeric vector is numeric, and the data type of character vector is character, and the data type of logical vector is logical. So that's how you can create vectors in R programming. In the same way, there is another data structure we can actually use in R programming, which is called list. So lists are data structures that can hold elements of different types. They are created using the list function. Examples of lists are, for example, in that case, lists are able to have multiple values of multiple data types within a single list. So it's that's why it's different from the vectors, where the value has to be of single data type. Here you can have multiple data types within a single list. So that's how we're going to define it. So first of all, I'm going to initialize a variable name list underscore var. Then I'm going to assign its value by using this assignment operator. Then I'm going to call the function list of R programming, and within those round brackets, I'm going to pass the elements of the data type which I'm going to assign through that list. And every element must be separated by a comma. So for example, one is numeric data type. Here A within double quotation is actually our character data type. Here 2 TRUE with all uppercase is actually a logical data type, and here 1 plus 2I is actually a complex data type. So you can see that each data type is different from the one another. So that's the advantage of using lists. You can actually store multiple data type within a single list. So that's how you can actually define a list. Once I define a list, I'm simply going to print its value by writing its name on simply printing its value. So now you can see our list can hold data of multiple different kinds of data. And let me just check the class or data type of the variable we have declared earlier. So let me just run this. Now you can see that the data type of the variable declared list underscore var is actually a list. So that's how you can actually define a list in R programming. And now if you have defined a list, you might be interested to extract a specific value out of a list. So how you can actually do that? It's quite simple. First of all, you are going to write variable name list underscore var, and then using this syntax here, double square bracket syntax, and within the double square bracket you are passing the index of the element. Here in R programming, the index starts from 0, which is quite different from Python programming, where the index starts from 0. So here in R programming, the index starts from 1. So that's why, so this here Python state, this R statement here will give us the first element of our list. In the same way, we can also extract another element by changing the index value. In here, I have changed the index value from 1 to 2 and have used the same syntax notation here, a double square brackets. So let me just run this block of code for you. Now you can see that that's how you can actually assess a specific value out of a list. Let's move on and discuss about matrix. So the matrix are two-dimensional data structures that contains elements of the same data type. So keep that in mind, that data has to be of the same data type. They are created using the matrix function. Example of matrix are such that I'm going to explain you right now. So first of all, I'm going to initialize a variable named matrix underscore var, And once I've done that, I'm going to assign its value by using this assignment operator. Then I'm going to call the matrix function of R programming, and within those R programming, I'm going to pass 3 input arguments. The first one is actually the data that will be used to create matrix. Here I have used 1 colon 6, which is a sequence of numbers from 1 to 6. Then I have to define the rows, how many rows the matrix should have. In our case, n rows is equal to 2. It means that it should have 2 rows. Then I'm going to define the column numbers, where the n col is equal to 3, which means that the column should be 3. So that's how you can actually define a matrix in R programming. So once we have done that, let me just run this block of code for you. And simply I'm going to print its value by writing its variable name in the search console, in the console, and by writing it in the value in the code, and it will then print the value on the output console. So now you can see that we have a matrix that has 2 rows and 3 columns. And I'm also interested to know about the class of the variable declared earlier. For that purpose, I'm going to use the function class of R programming, and I'm going to use matrix underscore var. So let me just run this block of code for you. Now you can see that the class of the data type of this declared variable is actually a matrix. So just like this, so it's a matrix. And you might be interested to actually access the value of a matrix. For example, you want to access a specific value out of a matrix. So how you can do that is quite easy to do. First of all, you are going to write the variable name matrix underscore var. Then using this square bracket, you are going to assign the position of the matrix. Here the index starts from 1. So whatever the position you want, for example, you want the element that is from the first row and the second column. So that's how you can do it. We will find the position 1, 2, and that will extract the specific value out of that matrix. In the same way, if you don't write anything in the place of rows and column, for example, if you don't write anything in the place of rows where you define the row element, it will means that you actually want to take all the elements out of all the row elements of those rows. Okay, so it means that you want to include all the rows. So in this case, I'm including all the rows from the second column. So that's how it is done. So let me just run this block of code for you. Now you can see that the first actually displays give us the value 3, which is at the first row and second column, and the second syntax here actually give us the value of second column and all rows, that is 3 and 4. So that's how you can actually access values out of a matrix. And finally, let's briefly discuss about data frames. I will discuss about data frames in another lecture in more details, but as we are discussing about the data types of R programming, so I thought it's necessary to actually briefly discuss about data frames in here, so you can actually have an idea how you can define multiple data types in R programming. So data frames are tabular data structures that can contain different types of data in each column. They are created using the data.frame function. Examples of data frames are included such that. So in order to create a data frame, first of all, we are going to initialize a variable name data underscore frame underscore var. Then I'm going to assign a value by using assignment operator. Then I'm going to call R function, which is data.frame. That will actually create the data frame. And within those round brackets, I'm going to pass data in the form of this notation here. First of all, this statement here will create a column name with values Alice and Bob, and this syntax here. So this syntax here, age is equal to C. You can recall that C is used to define what? A vector. So here we define age is equal to C 25, 30 will create a column whose name will be age and its value will be 25 and 30. And this Python, then I'm going, and for every column we are going to separate from another column by using this comma. Okay, so first we declare column name whose values are Alice and Bob, and then we separate it from another column definition by using comma. In the same way, we are going to use comma here and then define another column name whose name will be gender and its value will be female and male. So that's how you can actually define a data frame in R programming. And once I have declared and assigned a data frame, I'm going to print it by writing its name in the code, and then finally running the code, it will print the value in the output. So now you can see that I have created a data frame with column name, age, and gender. And the values in name are Alice and Bob, and the values in the age are 25 and 30, and the values in gender are female and male, as just we have declared earlier. So that's how you can actually create a data frame in R programming. Finally, I'm interested to know about the class of the declared variable data underscore frame underscore var. So let me just run this block of code. Now you can see that the data frame or the class of this declared variable is actually a data frame. So that was a comprehensive tutorial on data types in R programming. I hope this lecture have been helpful. If you have any questions regarding today's lectures or any questions regarding data analysis or data science, feel free to write down your questions in the comment section below. I will be happy to help you out and clear your queries or questions if you have. And the upcoming videos, I will be posting more videos regarding fundamentals of R programming, where I will teach you about the fundamentals of R programming. That's it for now. Thank you for joining me, and stay tuned for the next videos. Thank you. And please don't forget to like and subscribe to my channel for more informational content as this. Thank you.